Hello again, you lot. Time for the latest video in this series. I know it's not Christmas, but the gifts keep on coming with these videos. Now, for resource management, what I thought I'd do is I'd start with a run through of some key definitions. This not only will give you a strong foundation into starting the topic, because in year 11 you probably are doing it right now, or just about to start, or even just finished it. Maybe I can't remember exactly where you'll be up to. But in terms of this, it will help you clarify any misconceptions, and also this will give you a starting foundation, to make a strong kind of knowledge gain into this topic. Now, in terms of resource management, in the exam, you get question 4, question 5, and question 6. Now, listen to this very carefully. It's the most important sentence I've told you in a long time. You only need to answer one of those questions. Question 4, or question 5, or question 6. Again, every year, some students, guaranteed in your year group, will answer the wrong ones or will answer more than one of them. Don't let that person be you. Question 4, or question 5, or question 6. It depends on what you are studying. So basically, different schools around the UK decide to teach their students different questions. So what I mean by that is one school will choose water, resource management. Another school might choose energy. Now, it depends on what your teachers have chosen for you. In my experience last year at the school, it will be question 6 that you will be answering. Okay, but I need a hand from you guys here. I know some of you watch these videos. I'm hoping that a lot of you are going to start sharing these around and make sure that everyone has access to these. I really would appreciate that. But you need to let me know which ones you're studying. Okay, is it energy? Is it food? Or is it water? Because your teachers will be teaching you about one of these 3. Now, in my experience, it was, I believe, energy last year. But it might have changed. So you need to tell me which of those you are studying. Okay, put that in the comments below. Someone do it, someone be the hero, and then I can do some decent videos about that strand at a later date. But ultimately, water, food, or energy. Now, that's question 4, 5, and 6. So one of them is going to be food, one of them is going to be water, one of them is going to be energy. And how many of them do you have to answer? Just one. If you answer more than one, it's literally a waste of time. You don't get any marks for that additional stuff. Okay? Question 4, or 5, or 6. One of them. But for example, now if you're being taught about energy, you would answer the energy section, not the water, not the food. You leave them blank. Okay? Anyway, as an overarching theme, because it overlaps quite nicely, let's go over some key definitions. Okay, feel free to pause this video at any time and go back over it should you need to. Again, all of these won't apply to you, but I run through them anyway. So in agribusiness, this would be to do with food management and food resource management. That is farms that choose more intensive farming methods to buy modern machinery to increase crop yield. It's all about improving food supply. But again, you don't need to study that one. The same with aquifer. Unless you're doing water, you wouldn't study that. However, let's start with biofuel, because I'm going to go on the assumption that you are doing energy like we did last year. If this changes and one of you in the comments lets me know, oh no, Mr. Murphy, we're doing food. Oh no, Mr. Murphy, we're doing water. Then I'll come back to these and do them again at a later date. Let's start with biofuel. The third one down there. Pause the video if you'd like to, but make a note of that. Biofuel is where you can basically burn crops and vegetation and plants, and that generates electricity and heat. You can actually make electricity from biofuel, from burning plants and burning like dead crops, for example. The way this can work is if you burn crops, it produces smoke, which turns a turbine, which produces electricity. In terms of biotechnology, that's more about food, so we'll skip that one for now. Climate change, I hope you should know. In terms of decommission, that's the process of closing and safely disposing waste from a power station. This could be to do with energy management, couldn't it? It can cost millions of pounds and take like many, many years to complete. But to decommission is to close down and safely dispose of waste from a power station. Desalination is about water management. Drought is about water management. Energy deficit. Now, this came up last year. Spoilers for any mocks you might do. Energy deficit. A country that generates less energy than its population needs. So the supply is less than the demand. If, for example, I want to treat 11A1 to a packet of sweets each, and there's 27 of you, and I bring in 24 packets of sweets, there's a deficit there. I am short. I have less than I need. That can happen with food, that can happen with water, and it can happen with energy if a country doesn't have enough. So in this case, energy deficit is where a country generates and makes less energy than it needs, i.e. the supply, what it has to use, is less than what it actually needs. Therefore, you're going to get problems such as blackouts, for example. Energy mix. This is like a kind of pick and mix. It's different mixes. The composition of a country's energy sources. For example, is it water generated? Is it solar energy? Is it hydroelectric? Is it from fossil fuels? Different countries will have different mixes. Some will rely more on coal. Some will rely more on green energy, depending on the financial status and economic development of the country. Energy security. So that is the ownership and full control of a country's energy source, production and transportation. So the more secure you are in terms of your own energy, the better. For example, if a country relies on energy from somewhere else and this country can maybe up the price or suffers, for example, war, then you're going to have your own energy security hit. Many countries in Europe, like Germany, for example, relied on Russian energy. With the war in Ukraine, the prices were risen and therefore they became less energy secure. So they had to try and rely more on their own supply than what they were generating themselves. Energy surplus is almost the opposite to energy deficit. A country that generates more energy than it needs. Often here, these are areas with low populations and lots of natural resources, like for example, lots of solar panels in good weather. What they will do then is generate more energy than they need, and then they'll sell the surplus, they'll sell the extra to another country that maybe is in deficit. Fair trade, that's to do with food, famine's to do with food, fertilizer to do with food, food miles to do with food, obviously, same with poverty. Fossil fuels, just to clarify, this is year 8 stuff really, but fossil fuels are non-renewable. That means you can't renew them, they will run out. They are not finite, they're not infinite, they are finite, they will run out. Non-renewable sources of fuel that take thousands of years to form underground from dead vegetation and animals. That is how oil, coal and gas are formed. The fossils, that's why it's called fossil fuels, the fossils of dead fish from millions of years ago. Eventually, if we use these faster than they're being made, we will run out. And that is what's happening. In the next 100 to 150 years, we are running out of fossil fuels. That means we have to go towards maybe some solar energy. Fracking is to do with energy. It's the process of releasing trapped natural gas from shale rocks. This is a bit of a controversial one in the UK, but it basically involves high-pressure liquids being forced underground to cause rocks to crack to basically get that natural gas from below. It can be very environmentally damaging. That's why there's a bit of a debate about it, but it is also a good way of generating energy. That's why it's also done. It makes money. Geothermal energy, break that definition down, it's easy to work out. It's where water's pumped underground to be heated by magma. This back to the hazard stuff. And the water creates steam. The steam turns turbines. The turbines in generators produce electricity. So that movement from the steam causes it to turn around, and that's kind of spinning motion causes and generates electricity. Greenhouse emissions. So gases like CO2, methane, CFCs, for example, nitrous oxide, they are all greenhouse gases, and they thicken the Earth's atmosphere. So if you remember, it's like having many different blankets on you. They trap the Earth's heat in the atmosphere, but the more blankets you put on, the more greenhouse gases there are, the more heat is trapped. Therefore, the planet's going to get warmer. Climate change, global warming, etc. Hydroelectricity, well, hydroelectric energy, hydro, water, it's where it's energy produced by water. Electric energy produced by water, hydroelectric energy. Water normally trapped in a dam forces past the turbines. Again, this turns the turbines. This generates electricity. Hydroponics is about food. Importing is more about food, to be honest with you. Same as water, really. Irrigation is about food and water. Malnourishment is food. Malnutrition is food. Non-renewable, went over this earlier, but non-renewable is a resource of energy that could only be used once. It will run out. It's not infinite, it's finite. It will run out eventually. You can only use it once. So if you can recycle something, that's renewable. If you can't recycle it, if you use it once, it's non-renewable. Nuclear fusion, the process of joining atomic nuclei together to produce energy. That's just another way of producing energy for a country if they have the money. The next three are to do with kind of food and farming. I'll skip over those for now. Renewable. So renewable is primary energy that can be reused to produce electricity, or it has a short lifeline. So basically, it can be replaced. It will not run out. You can use it again and again and again. That is renewable. So you hear about this kind of aim and work towards renewable energy. That's because it won't run out. If you rely on something that's non-renewable, eventually it's not sustainable because it will run out. Whereas if you rely on something that's renewable, you can use it forever. Secondary energy is the product of primary energy, like electricity. So, for example, in like earthquakes and stuff, the primary effects happen first, and the secondary effects happen as a result of these primary effects. It's the same with energy. Primary energy happens, secondary energy happens as a result of the primary energy. Okay, for example, electricity mainly. Solar energy, you should know this one anyway. It's using solar panels to convert sunlight into electric. This word, sustainability, is relevant to all of them really. It's trying to conserve resources, so energy, food or water, for the future, whilst meeting the demand for goods in the present. So in energy's case, it's trying to conserve energy resources for the future, whilst also producing enough energy to live our lives today. Tidal energy from the tides, believe it or not. As the tides change, water rushes out to sea or in towards the land. And again, this movement turns the turbines, always about the turbines, turns the turbines, produces electricity through the kinetic energy. Water. I'll skip some of those. Down to wave energy, the second one from the bottom here. Wave energy is electricity generated by small turbines with floating buoys. So similar to the tides, but the tides go in and out. The waves are just coming all the time. So it's slightly different. But wave energy is, the water going through the turbines, turning them and causing electricity. And then wind energy. You know what these look like, the wind turbines? It's the same idea, just not with water this time. Wind energy uses wind turbines to drive generators that produce electricity. So right there is a run through of the key energy definitions. Okay, there's more there if you want to have a look at the others as well, but I wouldn't waste your time doing too much of that stuff. Please put in the comments for me if you're doing water or food and it's changed from last year, and I'll make amends to this list and do the video again. Otherwise, I'm hopeful that a few of those definitions can be quite useful to you. As a heads up, last year and the year before that, actually, there's always a 2-mark question that asks about a definition. So you could do with knowing as many of these as possible. It will also help you in terms of approaching your 4 and 6 marker. Note, there is no 9 marker for this section. Any questions, as always, hit me up in the comments, and I'll see you soon.